The purpose of this video is to discuss simplifying expressions, or as some people refer to it as, combining like terms. We'll talk about what like terms are, what we can do with them, and what some of the strategies we might want to use to help us combine them are. So, let's get into it. Here we have the expression 3x plus 2 plus 5x plus 7. Our goal is to simplify this expression down so that we don't have as much going on here. We got a lot going on. We've got 3 different operations, we've got 4 terms, and we want to try to simplify this. So, like terms are when the numbers are the same type. As in, here I have a 2 and I have a 7. They're the same type because all they are their number. Here I have a 3x, and here I have a 5x. These are the same type because they both have the same variable. So I can combine these. And one way we can think of doing this is using the commutative and the associative property. The commutative property tells me I can change the order, that I can put things in different orders as well, or as long as I'm using just addition. So instead of thinking of it like this, I'm going to change the order of our middle terms. So it's going to become 3x plus, now I'm changing the 5x to be here, plus 2 plus 7. Now I've put the like terms near each other. This isn't a very vital step if you are good with doing this in your head, but to help you organize, it's not a bad idea. Now, I can add these two together. They are like terms, I can simplify them, and 3x plus 5x gives me 8x. And I can do the same thing with our 2 and our 7 because they're like terms. 2 plus 7 gives me 9. And I can combine these two down to become 8x plus 9. This is the exact same expression as before, just simplified so that we don't have to worry about as much going on. Alright, let's try a different one. This time I have 9 minus 2x plus 3x squared plus 7x. If you want to pause the video and attempt it on your own, good luck. Otherwise, let's take a look and try to identify our like terms. 9 is all by itself, and in our other 3 terms, we really don't have any other numbers that are just by themselves. Everything else has a variable. So 9 is going to stay as it is. Now let's look at the negative 2x, or the minus 2x. This has just an x. The 7x over here also has just an x. So these are like terms. But you may be wondering, hey, this has an x too, the 3x squared. The problem here is, though, this isn't just an x. This is an x squared. So since it's an x squared, it has that exponent on it, it is not the same as x and x. So we can't say that this term, 3x squared, is the same as negative 2x and 7x. Well, just like before, I want to rearrange things to try to make my expression a little bit easier to simplify. And since I have minus, I'm going to rewrite this problem as, instead of being 9 minus 2x, I'm going to make it 9 plus a negative 2x. That way, the value of that 2x is maintained when I combine it with our 7x. So if you have any subtraction going on, it's probably in your best interest to change the subtraction to addition and make whatever is after it a negative. So, let's rearrange things. I've got 9 plus, and I'll move the middle 2 terms again. So that'll be 3x squared plus, we've got a negative 2x now, plus 7x. And I can combine my like terms that are over here. nothing is going to happen with our 9 plus 3x squared. They're going to stay exactly as they are because they're already as simplified as they can be. What's going to happen over here is I'm going to combine negative 2x and 7x, and these are going to turn into 5x. The rest of it stays as it was, so I have 9 plus 3x squared plus 5x, and then we're basically done. The only thing that is left that we could do is put it into a standard order where the highest term with the highest power goes first. So we could rewrite it as 3x squared plus 5x plus 9. And that would be our final answer. Alright, let's try one more. Make it a little tougher this time. See if you're up for the challenge. Alright, here we have a times b plus 3a squared b minus 2ab squared plus 5ab. If you want to pause the video and attempt this on your own, good luck. Otherwise, first, start looking for any like terms. We want to find anything that has the exact same variables or is just numbers. And it's pretty obvious right from the get-go, we don't have anything that's just numbers. Everything has at least one variable. So I've got to compare AB, my first one, to everything else. And what we hopefully notice is that this has a and b, but it's a squared b, so it's different. This has a and b, but it's ab squared, so that is also different. And then my last term over here is just ab. So this, our 5ab, and our ab are the only terms that are the same. Everything else is going to stay as it is. So I can rearrange things. I'll have 3a squared b minus 2ab squared plus ab plus 5ab. Over here is the only time I can do any sort of combining of our like terms. So I have AB, which even though it's not there, it's considered a 1AB. So I have 1AB plus 5AB, which when we combine it all will give us 6AB. And over here, these don't change. They are not the same term. So they'll just stay 3a squared b minus 2ab squared plus our new term of 6ab. And now everything is combined down to as far as it can go. Now, we're going to move on to our last little topic for this video, which is how to use the distributive property to help us with combining like terms. So let's get into the distributive property. So here up top we have an example of the distributive property. It says 3 times the quantity 4 plus 8 equals 3 times 4 plus 3 times 8. Basically, the distributive property says if we are multiplying something outside of a set of parentheses by something that is inside the set of parentheses with at least one operation, that is addition or subtraction, we have to distribute what's outside to each piece on the inside. So that's how we get 3 times 4, and then when we distribute it this way, we get 3 times 8. That's the distributive property in a nutshell. Now, how can we use this to help us? Well, here I have 15 times 103. 103 by itself is not very easy to multiply by 15 in our head as we are becoming better at this kind of thing. But what we can do is we can break apart 103 into numbers that are easier to multiply by 15. That way we can multiply them together and get a final answer. So I'm going to break apart 103 into two easier numbers to multiply by 15, and that would be 100 plus 3. 103 are much easier to multiply 15 by than 103 on its own. This is much nicer for mental math. So now I need to distribute. I'm going to distribute the 15 to both pieces. I'm going to have 15 times 100 plus 15 times 3. And now, using some tricks that I may have learned up to this point, 15 times 100, well, that's going to be the same thing as 15 times 1 with 2 zeros after it. So that's going to give me 1500 plus, and then 15 times 3 is 45. And I can combine those to finally simplify and get my final answer of 1,545. And that's how we can use the distributive property to take what looks like maybe an uglier number and multiply it a little bit easier, hopefully doing some mental math. Alright, let's try another one. Alright, for my last example here in this video, we're doing our distributive property again, and I've given us kind of a tough one. Something that you definitely wouldn't want to try doing as mental math, but instead breaking it down using the distributive property. So I have 3 times 978. I don't want to try to do that right away, and it's always good if we can do it without a calculator. So let's split up 978. Last time we split 103 into 100 plus 3 to get two terms, but this time I'm going to want to get 3 terms to make it as easy as I possibly can. So if you want to pause the video and see if you can figure out how we're going to break this down, or if you want to try it on your own, feel free and good luck. Otherwise, I want to split this down into basically an expanded form using our place values. I'm going to have 3 on the outside, but that 9 is in the hundreds place, so I'm going to have 900 plus that 7 is in the tens place, so I'm going to have 70 plus that 8 is in the ones place, so I'm going to have 8. Now, these are much nicer numbers for us to work on. I'm going to do my distributive property, so I'm going to have to distribute the 3 to the 900, the 3 to the 70, and the 3 to the 8. That's going to give me 3 times 900 plus 3 times 70, and lastly plus 3 times 8. These, like I said, should be much easier for us to do mentally. 3 times 900 is 27 with 2 zeros. 3 times 70 is 21 with 1 zero. And 3 times 8 is 24. So now I can add all of those up. And if I add 2,700 plus 210 plus 24, I'm going to end up with 2,934. And that is my final answer. Alright, I hope you have found this video on simplifying expressions or combining like terms useful. Good luck.